Good morning, everyone. Welcome back. Thank you for joining us. We're going to get you through this Monday. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, Science and Technology Channel.
Yep, and we are talking about a freezing dust.
Yeah, this is a strange one.
It is strange.
But, I mean, it could be critical if planes go through this. And
just Sasquatch.
Exactly. We get Sasquatch to watch it, make sure we know where they are. New research based on decades of satellite observation reveals an unexpected atmospheric connection. Mineral dust from distant deserts can trigger the freezing of clouds in the Northern Hemisphere. Why the Northern Hemisphere? Why not? Can the Sahara dust freeze in the... Why? I don't know. I'm just the messenger.
Does anything freeze in the Sahara?
I don't know.
I don't know.
A new study has found that tiny dust particles traveling from distant deserts can help trigger the freezing of clouds in the Northern Hemisphere. This subtle atmospheric process influences how much sunlight clouds reflect back into space and how they produce rain and snow. Because of these effects, the mechanism could play an important role in improving climate projections. Would you like to know more?
Using 35 years of satellite data, an international team led by ETH Zurich investigated how mineral dust affects cloud formation. These particles are lifted from desert surfaces by strong winds and transported high into the atmosphere. Once there, they can act as seeds that cause droplets into clouds to freeze. The effect is particularly important in northern regions where clouds frequently form at temperatures slightly below freezing. Okay.
Quote, we found that where there's more dust, clouds are much more likely to freeze at the top, explains Diego Villanueva, a postdoctoral researcher from atmospheric physics at ETH Zurich and lead author of the study. Continuing his quote, this has a direct impact on how much sunlight is reflected back into space and how much precipitation is generated.
The scientists concentrated on mixed phase clouds, which contain both supercooled liquid droplets and ice crystals. These clouds form in temperatures between negative 39 degrees Celsius and 0 degrees Celsius, which is, for us Fahrenheit guys, negative 38 degrees Fahrenheit. That doesn't make sense. That's not enough difference to 32 degrees Fahrenheit.
Yeah, once you get to 0, I think it has to do with below freezing. But it's a 70-degree Fahrenheit swing. That's crazy. That's like here in the high desert.
From negative 39 degrees Celsius equals negative 38 degrees Fahrenheit. That's got to be a misprint.
Hey, man, I don't do
I
the
know,
math.
I know. We're just the messengers, but that's...
I don't do the math, okay?
Gotcha. They are widespread across mid and high latitude regions, particularly over the North Atlantic, Siberia, and Canada.
Okay, so we're talking hemisphere. So that's like take the equator and everything north of the equator. That's the Northern Hemisphere. So it could be Russia, Canada, United States, Finland.
Okay.
Mixed phase clouds are extremely sensitive to environmental conditions. One key factor is the presence of ice nucleating particles, not making that up, which often originate from desert dust aerosols that have traveled long distances through the atmosphere.
To investigate the relationship, the researchers compared satellite observations of dust concentrations with how often clouds developed that ice at their tops. A clear pattern emerged. When dust levels were higher and temperatures were lower, ice-topped clouds appeared more frequently. According to the team, this large-scale pattern closely matched predictions from laboratory studies that examine how mineral dust causes water droplets to freeze. Okay.
Quote, this is one of the first studies to show that satellite measurements of cloud composition match what we've known from lab work, says Ulrike Lohmann, senior co-author and professor of atmospheric physics at ETH Zurich.
The freezing of clouds plays a key role in the climate system. It affects the amount of sunlight clouds reflect into space and determines how efficiently they release release precipitation. Climate models rely on accurate descriptions of these processes, yet researchers have long lacked global observations that clearly connect airborne dust with cloud freezing.
Okay, I just want to make a point. We're broadcasting this on Monday the 30th. This is not an April Fool's story.
Not yet.
It's not.
Not yet.
Okay? Okay.
And we wouldn't do that anyway.
No, we wouldn't do that to you, no. We're cousins. We wouldn't do that. The new results establish a measurable relationship between atmospheric dust and the occurrence of ice at cloud tops. This provides an important reference point that could help scientists refine climate simulations.
Scientists have studied the freezing of individual water droplets for decades, often focusing on microscopic processes. The new research shows that cloud glaciation follows the same basic behavior seen in those small-scale experiments, but across far larger atmospheric systems.
This connection links extremely small structures on the surfaces of dust particles measured in nanometers. 1 nanometer is 0.0000004 inches. That's 7 zeros in there. With cloud systems that extend for kilometers and can be observed from satellites in orbit.
However, the influence of dust on cloud freezing is not uniform worldwide. In desert regions such as the Sahara, which we just talked about, I don't think anything freezes in the Sahara, right? Maybe so. You know, we have freezing and we're in the desert here. So clouds are relatively rare and rising warm air may limit freezing. In the southern hemisphere, sea salt and other marine aerosols may play a larger role than desert dust.
The researchers say additional studies are needed to determine how other factors, including updraft strength and atmospheric humidity, shape the freezing process, aka give me your money. Even so,
can't these guys do anything without money? Jeez.
We want cash money.
Yeah.
Even
yeah,
so
we can study our freezing dust. Okay. All right. There you have
love
it.
is exciting and exhilarating, but it's not free. Give me your money.
Yeah. These studies cost a lot of money. So
the study highlights an important conclusion. Tiny grains of dust from distant deserts help influence the clouds overhead, and those clouds play a role in shaping Earth's future climate. True, that's a factual statement.
So says Steve. And the people that wrote this article. So, all right, there you go. One down. We'll see you this afternoon. Thank you.
We'll see you. One down.